Hello, everyone. Good morning. I hope you guys are doing great today. I just wanted to tell everybody that you guys did an excellent job at the safety stations activity yesterday. I looked at the work that you turned in and it was very well done. So good job on that. Today, we are going to learn to make measurements as if you were a real professional chemist. Okay, now I know you guys have done lots of measuring before, so we're not going to cover the basics, but we're going to focus on the skills that professional chemists have. Okay, so here are our two main goals for today. You're going to learn to carry out measurements of liquids using something that we call the meniscus, and I'm going to explain to you what that is. Okay, and you're also going to learn to make measurements with the correct amount of precision. Not too little, not too much, just the right amount. So let's get started. So before, when you made measurements and you saw this graduated cylinder yesterday when you were doing your station activity, you would look at the main line. So here we've got 10 mils and 20 mils, so each line must be 1. So in this picture here must be about 18 mils. And that's what most of you guys estimated yesterday when you were at this station. Okay. One other thing I want to bring to memory really quick is about place value. It's going to be really simple. So when we have a number like this first one is called the hundredths place, tens, ones place, tenth, hundredth, and thousandth. Okay, so that's just a quick review of the different names of place value. All right, so coming back to that problem that you guys worked on yesterday at the station activity, here are some of what we call valid measurements, okay, based on what you guys turned in yesterday. So as you see, there are actually 3 correct answers, which is not typically something that students think of like science and math. There's only like 1 correct answer. But for this measurement, there's actually 3 different possible answers that are completely scientific valid, okay? And then here is an answer that is actually not scientifically valid. Okay, so 18 mils would not be a correct measurement for this, which I know what you guys are thinking. 18 mils and 18.0 are like exactly the same. Okay, so you do need to have 1 decimal place every time. What is it? So we're going to talk about that, okay, because actually 18.0 and 18 mils mean 2 very different things scientifically. So let's just get into it so that maybe this will make more sense. Okay. So here you have a ruler on the top, and as you can see, we have a 5 centimeter mark and a 6 centimeter mark. So the smallest mark here gives you the 10th place. So 5.1, 0.2, this is 5.5 right here, 5.6, 5.7. So that arrow is really close to 5.7, but it's not quite 5.7. So we know that there's something that we need to do, okay? Some estimation that we're going to have to do. So here are some examples of valid measurements for this. 5.71, 72, 73, 74. Okay. Now let's take a step back and let's look at this carefully. 5.7 are the digits that we are sure of because the tool gives you the ones place and the 10th place. So you estimated the 100th place. Okay. So there's a sentence that kind of summarizes that concept, and it says this: a valid measurement always has 1 estimated digit that is 1/10 of the smallest mark. So on the ruler, the smallest mark was the 0.7, okay, the 10th place. So you estimate the 100th, 1/10 of the smallest mark, and you only add 1 estimated digit. Not 2, not 3, not 0, 1. And scientists do that all the time for consistency, okay? So that's what we call a valid measurement. So let's look at this graduated cylinder. Kind of same concept. There's a measurement between 5 and 6. The smallest mark is the 10th place. So we have to estimate the 100th. Now I noticed that a lot of you guys yesterday had questions on because you see there, the liquid doesn't form a straight line, it forms that little curve, okay? So we're measuring like at the end of the curve where it's highest, in the middle of the curve, or in the middle section, but at the bottom of the curve, Okay, and the answer is we always measure at the bottom of the curve. That curve is called the meniscus, okay, and we always measure from the bottom of the meniscus. So when I look at the bottom of the meniscus, this should be around 5.4, but remember I got to go to the 100th place because the smallest mark on that graduated cylinder is the 10th place. So 5.40 is what most people probably would have gone for, but you can go a little bit under or a little bit above. And all of these would be considered valid measurements because they go to the 100th place. Okay? All right, so now we're going to practice, and I'm going to give you some feedback. So please pull out your phones or use one of the Chromebooks. There are some practice problems for you in Google Classroom. Let's do them right now. I'll be walking around answering any questions, and then I'm going to look at the results and we'll go over a couple of the questions. Okay, good job guys on doing that. So here are a couple of questions for us to go over. Okay, on that top ruler there, you see the ruler has the 100th place, 200, 300, and also the 10th place. So we have the 100th place and the 10th place. So we've got to estimate the ones place. Okay, so some valid measurements there would be 236 all the way to 239. All right. Again, we've got the hundreds and the tenths, so we estimate the ones because it is 1/10 of the smallest mark. That graduated cylinder, we have very small measurements. We've got 0.4 plus one more digit. So we've got the 10th place and the 100th place. So we've got to estimate the 1000th place. So here are some valid, all of these are correct answers for that, that picture, okay? Some incorrect answers, okay? So this, for example, here has too many estimated digits, okay? They're estimating the 6 and the 0.0. So you're estimating the ones in the 10th place. That's too much estimation. We only want one estimated digit. Here are some incorrect answers from the second graduated cylinder. That first incorrect answer says 0.45. Well, that's what we are sure of. There's no estimation there. And we always want to have one estimated digit again for consistency, okay? Or 0.4530, well, in that case, we're estimating two digits, and that's too much estimation. So that rule, always one estimated digit, that's 1/10 of the smallest mark. Every scientist in the whole planet uses that rule to make measurements. And that's how we're going to make measurements in this class every time we do a lab for the rest of the year, okay? All right. For the assessment performance for this lesson, students will be assessed with tools that chemists use in the lab, such as graduated cylinders of different sizes, flasks, mass balances, burettes, and eudiometers. Students will rotate through stations. Each station will have an instrument with a substance, such as a graduated cylinder with 35 mils of ethanol, for example, or other substances. Each station will contain a picture of a real chemist using that tool to increase the authenticity of the assessment. Finally, to enhance retention and transfer, following this activity, students will perform a density lab. The density lab is an introduction for the properties of matter unit, but it also allows students to demonstrate procedural knowledge regarding measurements in the context of a lab, which is more authentic than just doing stations with isolated measurements. Thank you.